Hello and welcome everybody. Welcome back again to another new video of Linux Core for Hackers course part 5. So this video is going to be the part 5 of our course Linux for Hackers. So if you haven't watched our previous video of our course Linux for Hackers, then I will recommend you to check out my full playlist on my channel. Head over to my channel or my podcast section. You will be find some valuable information about Linux. So I am assuming that you have watched my previous video on the topic of users and group, where we have discussed users and groups in Linux and how they created, how they managed in Linux operating system or Unix like system. So in this video, we're gonna learn about the most popular and most important topic of Linux, which is permission, the file and directory permission on Linux, and how the permission actually work on Linux, and how you can implement permissions in order to secure your Linux operating system. So without wasting more time, let's get started. So, as you can see on the screen now, this is a popular article from Red Hat, where it is a very popular distro in Linux, where you can read about the file permission and all the details about it. So, basically, let us first understand what a file permission is. So, as I have explained on some my previous video, I think that was my part 2 or maybe the part 3 video of the Linux for Hacker course, where I have discussed about files, what a file is and what a directory is. So, if you haven't watched that video, then I will recommend you to first complete that, then come to this video. Or without watching those videos, you can't get understand what I am gonna talk in this video. So just watch first and then come into this video. So I'm assuming that you have completed those part of my course before. So let us just begin that what a permission is. So basically in Linux, the permission is basically some kind of security mechanism implemented in Unix like operating system that basically determine who can access some resources or who are not allowed to do that. Or you can say that the permission is some kind of a security mechanism implemented in Linux that basically defines whether you are able or you are allowed or you are permitted to access such files and directories, or you are just not allowed to do that. So let us just understand this thing with a simple example. Let us just focus on this diagram. So as you can see on the screen right now, there is three entity basically. One, this is the house basically, where the some kind of sensitive data has been stored, or some kind of sensitive information is inside in the house. And in the right side, this is the basically a house owner, as you can consider this is the house owner. And in the left side, there is a bad guy, or you can consider this guy is a unauthorized entity basically. So this is the unauthorized entity or the unauthorized guy, and this is the house owner. So what if the unauthorized guy or the bad guy is enter into the house and steal some sensitive data? So this will be drastically effect on the house owner, right? From unauthorized entity, or the bad guy who is basically trying to steal their sensitive data in from their house. So this is the case where you need to understand permission. So think about the gatekeeper or the security guard, how it will, and the security guard will get to know about who is the bad guy and who is the house owner, the actual owner of this house, and who the security guard who is standing at the gate. How do he know that who is the actual owner of the house or who is the bad guy? So here it comes the permission. The security guard basically he has the permission list basically, or you can consider it as the security guard has a list of permission that basically defines who has the right permission to access or to get into the house, or to get inside the house. By watching the permission list, which have the security guard, he can analyze, or he can identify who is the bad guy here and who is the actual owner of the house. So here the permission list confirm the actual owner of this house, and the security guard who is standing at the gate, will they allow or not. So same as the Linux here, that the Linux in the Linux there are several kinds of permission which we are going to learn about in detail in this video. So stay tick around this video. So in simple word, the permission is basically a kind of security mechanism that basically defines who is authorized to access a certain kind of resources, or who are not allowed to do that. So if you scroll on this page of redhat.com website, then you can find there is some kind of topic which basically says that how do you view Linux file permission. So basically we are going to cover these things in our in practical. We will do these things in practically in my on operating system. This is here, that is my Kali Linux operating system. I will show you as always I show in my video. We will perform and we will analyze the permissions, and how we can view the permissions of files and all the necessary details about it. So, for some technical reason, I was unable to boot up my Kali Linux VirtualBox machine. So, I have booted up here the parent operating system, as you can see right over here. So, let me just show you how we can implement the permissions practically in my OS. So, let me just open my terminal over here, and you can see this is my terminal. And we will start from how we can view Linux file permission. So in the left side you can see the theory, and on the right side you can see the practical implementation. So in this way it will gonna very easier for you to understand. So, as I have told you in my previous video that about the ls-l command. So, whenever you hit the ls-l command, then you can see a long list of all the files and directory present on the current directory where you are right now. So, so basically, when you long list a directory or a file, then you can see the detailed permission of that particular directory or the file. So let us just understand how you can understand the permission of a file basically, or whether the or what permission is a set to a specific file. So let me just create a another directory to illustrate better. So I have basically created a example directory over here, and you can see this is my directory inside my home directory, and I have some kind of files and a directory inside my example directory. So if I go to show you, then I will type the ls-l command, and you can see over here. This is there is a two text file, which is in the number one is file.txt, and another is the info.txt, and another and this is a test, which is a directory. So let us just understand these things. So basically in Linux, whenever you type the ls-l command, the first these things will define what the permission the file have. Exemplary diagram on your left screen, where you can very much dictate that this permission list, or you can say the permission symbol basically. So if you focus on my file.txt files permission set, or the permission symbols over here, then you can see in the first place or placeholder there is a hyphen symbol, or you can consider a minus symbol. So what does it mean basically? So the hyphen symbol basically means stands for the file type, or it basically defines the regular file extension. If the file type is a regular file, or you can say is a simple file, then you can see the hyphen option over here. If you move forward to the right placeholder, then you can see in my file.txt file this stands for R, or in the next place there is a W. So what does it mean? What does it mean for R and W? So the R stands for right readable permission, and the W stands for basically the writable permission. And if you are seeing this is a X in my test directory, then this stands for executable permission, which you can see in this image on the left screen. So you can now differentiate between the file.txt file and the test directory, basically, where the first letter here is the hyphen symbol, and in the test folder it is D. So the D basically stands for the directory, or it basically specify whether it is a directory or basically a file. So as because the test is a directory, so the first letter is a directory D over here, and these are the files, so that's why it is a hyphen symbol. So now you might have a question over here that I have said that this hyphen symbol basically stands for the regular file extension or the regular file symbol. So there is some kind of hyphen symbol after the R and after the W, basically. So after the last of this index, then you can say that is it a regular file? Then the answer will be no, basically. So if the file has the hyphen symbol at the beginning, then it will be considered as a regular file. And if it has after the beginning, or the in the second placeholder or in the third placeholder, then it is basically it is basically meant to the denied permission, or the permission hasn't specified yet. Or if the all the row is empty, or the permission less, then it will be the hyphen option only. So in the permission symbol, there is basically 10 placeholder. As you can see on this image right now, there is a 10 placeholder. The first one is for the what type of file, whether it is a regular file or it is a symbolic link. We will be learn what a symbolic link in some further videos. So for still till now, you can consider the first placeholder is for the file type, whether it is a directory or a regular file, and the next three placeholder is for the user permission. You can see on this image, and that the first three placeholder is for the user, and then the after the three placeholder is for the group, and the last three placeholder is for other. As we have learned in our previous video about users, groups, and others. So if you haven't watched that video, then I will recommend you to watch first. Then it will be easier for you for this video. So, what does it mean? Let us just see with a quick example over here. So, if I list it, then you can see the file.txt file over here. Then, as I have as I told you that the first three placeholder is for the user, basically. So, let us just explain it more. So, you can see who the user of this file. This is this placeholder or this column. You can find the user of the file, and the second column is for the group, basically. So for the file.txt file on my Linux OS, the user of this file.txt is Rajan, and the group is the root. So basically Rajan is the user of file.txt, and if we consider the info.txt as compared to the file.txt, then you can dictate that the info.txt files user is root, whether the file.txt's user is the Rajan, whether the group might be same. All the file and directories groups are the root, basically. So let us just explain the RW and the hyphen permission stands for that the Rajan user has the read permission and the write permission over the file.txt, but not the executable permission, as the executable placeholder is empty by the hyphen symbol. So the Rajan user will be able to read the file.txt's content, and to write into the file.txt, but will be not will be able to execute the file if it will be a executable file like .sh or file.sh like something. So if you see the left side image over here, then the user has the read, write, and executable permission. Also, the group has the read, write, executable permission, and the other user has the read, write, and executable permission. So you now might have some kind of doubt regarding what is the read permission and what is write permission and what is executable permission. So let us just understand it more deeply. So as you can, if I show you, then this is the section where the read, write, and executable permission are described briefly. So I have talked about you to view file permission and who they apply to and how to read file, what permissions are enabled or disabled. But what to do these permission actually do in practice. So the first one is the read permission. So the read permission basically allows you to read the content of that particular file. It as simple as its definition is the read permission is used to access the file's content. You can use tools like cat or less, what we have learned in our previous video about the cat command basically. So on the file to display the file's content basically. So you could also use a text editor like v or gedit or nano to display the file's content, which we are gonna see in our further video about the text editors present in our Linux. So don't get worried about it. So the read permission is required to make a copy of a file because you need to access the file's content to make a duplicate of it. So that's it, the read permission. So let us come to the write permission. So the write permission is basically a kind of modifiable permission. If a user has the write permission over some kind of file, for example, in my case, the file.txt, the Rajan user has the write permission. So the Rajan user will be able to modify the file's content. So that's as simple as the definition says, that the write permission allow you to modify or the change the file's content. Right permissions allow you to use direct append or these kinds of operational, you can say the operator will be used to make changes into the file. So without the right permission, changes to the file's content are not permitted basically. So the another cool permission is the executable permission. So the executable permission allow you to execute the content of a file. It basically typically executables would be things like commands, or it can be like compiled binary application. However, execute permission also allows someone to run bash shell scripts, Python programs, and a variety of interpreted language. So that's the executable permission, which is basically allows you to run that particular script, or it might be a program, it might be some kind of binary. So these things. So now you have now understood that what permission is and how it basically set to the user, and you can now able to read these symbols and used to specify the what the file, what type of permission the file has on the system. You can read it by these symbols. So let us now move to some more deep into this permissions of files and directories so that you can understand these things deeply and practically, how you can implement, how you can set some kind of specific permissions into the files. And let us now do a practical. So as you can see here, this is on the right window, that this is my parent operating system, and I have some kind of files such as file.txt, info.txt, and test. So let me just insert some data into the file.txt. So let me just check who am I. So as you can see, I am the user Rajan, the owner of the file. So I can, as I have the read privileges or the read permissions, or also as well as the write privileges to the file.txt. So I'm now able to modify the file's content. So this is the column. You can see there is all zero over here. That basically defines the content length of that file. So as these files have nothing inside it, so that's why these are zeros. So if I input some kind of data into this file, then it will be modified and it will be implemented. And this column specify the date and the time. So let me just insert data into the file.txt. I will use echo command. So if you are unable to understand what I am doing here, then watch my previous all videos. Then you will be able to understand these commands and these use in details. So let us hello world. So this is the hello world which I am inserting into file.txt, and I will hit enter, and this command has been executed successfully. And after I list it, then you can see in the zero section where it was 0, it is now 14. This is basically says that the 14 bytes of data the file.txt hold. So if I show you the file.txt content, then I will use the cat command, then file.txt, then you can see this is the file.txt its content which we have inputted the hello world. So why I am showing you because I am explaining the permissions or the privileges on Linux basically. So as we have shown that the R stands for read privileges, and the W stands for write privileges, or you can say the permissions. So as I have the write permission and the read permission on the file.txt, that's why I was able to modify the file's content, and I was able to see the file's content what is inside it. So if I don't have the didn't have the permission, if we have uh, just imagine that in the R and W section, if we have the hyphen or hyphen symbol, that means that we don't have the privileges or the permissions on the file.txt. In that case, I might not be able to see this file's content or to modify this file's content. So it will simply throw a error that permission denied. So let us just start by doing by modifying the file's permission, and how you can modify file permission to set it. So basically in Linux there is a command the which is the chmod command. You can see here let me just show you chmod. This is the command. This command is basically used for changing a file's permission. So then how you can change a file's permission? So to change the permission, you need to familiar with chmod command and some attributes of chmod command. So let us just change the permission of file.txt. So as I am the owner of the file.txt file, who is Rajan, so I can change the file's permission. So, for example, I want to set the file.txt to execute it. So, as the it is a txt file, so it technically it cannot execute something as it's a text file. But I can set the permission over here. You can see now this is a hyphen symbol right over here, as we don't have the as I didn't set it the executable permission into the file. So let me just give the executable permission to the file.txt. So in order to do that, you need to give the chmod command and then plus. The plus symbol is basically for assigning permission, and if I use the minus symbol, and it is for the removing permission or to revoking the permission. So in my case, I want to grant permission, so I will use the plus symbol over here, and then I want to give the file.txt executable permission, so I use the X symbol. But before that, I need to make sure that who I want to give that permission. So I want to give that permission to myself, the user of this file. So for the user, I want to specify the U over here, then plus, then X. The X is for basically executable permission. Then I will specify the file.txt and hit enter. And you can see command has been executed successfully. And if I again long list the file, then you can see the color also has been changed, and here you can see this is the X symbol. That basically directly means that the file.txt now has the executable permission. As you can see here, this is from the diagram. Now the file.txt has the executable permission, as it was before. That was a hyphen symbol, so that's how it works. So, what if I want to remove that permission? For example, if I want to remove the executable permission from the file.txt, then I will use the same command again. But in this case, I will use, instead of using the plus symbol, I will use the minus symbol. This basically tells that I want to remove or I want to revoke the executable permission from the file.txt, and I will hit enter, and you can see. If I again use the command file.txt-l, then you can see, you can compare this, this with this. Then you will able to know that how we can remove how we have removed that executable file permission from the file.txt. Now it again has been set it to hyphen option, which is the blank permission, or you can say the no permission. So this command is not only applicable for the executable permission. You can also here in the place of X, you can specify R, or you can specify U. If you can specify, sorry, W. So according to your requirement, whether you want to remove the write permission, or you want to grant the write permission, or you want to remove the read permission, or you want to grant the read permission, you can use the plus symbol or minus symbol, and you can use the W and R over here. So I will show you another example. Then it is the task for you to do, to practice to with it basically. So let us just if I want to remove the write permission, then I will use the hyphen then W. It basically remove the write privileges from the file.txt for the user Rajan. Here I have specified U. That means that I am removing or I am revoking the permission from the user of the file. And if I show you, then you can see on the place of W and X, there is nothing. There is the hyphen symbol. So it basically means the user Rajan now has only the read privileges, not the write privileges. So if I show you the proof that it has been granted or not, then I will try to write into the file. So if I do it using using echo, then for example, and if I try to write into the file.txt, then you can see the error message, which is permission denied. That's because we have removed the write permission from the Rajan user. So that's how it basically works. So also here is a case that if I use this command, for example, if I use chmod, then plus, then R, which is basically, sorry, not R, I will specify over here, I will specify W, and then I specify the file name, basically file.txt. And what if I give this, and as you can see that I haven't specified to what user I am assigning the right privileges or the right permission. So what it will do, what do you think? So let us just see. So if I again list it, then you can see that if I don't specify the user over here for what I am assigning my privileges or for what I am assigning my permission, then it will also set that particular permission to the current user only. So in this way also you can use this, but it is not the efficient way to set permission. It will sometime it will set unnecessary permission to others and groups basically. So always specify to whom you are assigning the permission by specifying the username or the U symbol basically. In the similar way, you can also assign permission to groups and to the other user. So let us just see a quick example over here. As you can see, currently we have only write and read permission, and the group also has the write permission, but not don't have the read the write permission. Basically, the group only has the read permission, and the other user only have the read permission. So what if I want to set other user to write into the file.txt. So in this case, I need to assign others to write privileges. So how can I achieve that? So I will use the chmod command and then use the plus icon to assigning the permission. But before that, I need to specify to whom I want to assign. I am assigning my permission. In this case, I am assigning others. So that's why I will use O, the cap, use the small O. That doesn't but I think you can use the small or basically over here. So after that you need to specify what permission you are granting. So I am here specifying the W for the write privileges, and then the file dot txt and then hit enter. And if I again list it, then you can see in the file.txt in the other section the write permission has been modified if you compare to the previous output of my command. So in this way I can also assign other user to some kind of specific permission. So if I want to remove it, then you just need to change the plus icon into the minus, then it will work. So same in the same way, you can also assign permission, permission or some kind of other permission to groups only by specifying the G option over here. And if I then you can see also you can see the group where the root group. What is the group of file.txt over here? This is the root group, or the group name is root. And now the root group also has the right privileges on the file.txt. So, if I want to remove or if I want to revoke the right privileges or the right permission from all at a in a single command, then I will use the chmod. Then I will use the user for user. I will use u. Then G for the group and O for others. Then I will use minus and then W and to file.txt. And you can now see all the right privileges which we have set it before has been removed or has been revoked from the file.txt in a single command. So in this way you can smartly use the chmod command also. So here I am not doing all these things. I am not removing all permission, not assigning all permission. I will give you some specific instruction to operate or to play around the file permission. It is the task for you to implement practically on your hands-on practice. So it's up to you now. So now let us come to another technique of assigning permission, which is the numerical format. So whatever we have seen right now, that was the basically you can say symbolic format basically. So as we have seen the permission, the removing functionality, or you can say the granting permission, whatever we have seen right now till now, that was the symbolic permission of a symbolic method of assigning and removing permission. But there is another method which is called numeric method. So, what does it mean? Let us just explain. So, as you can see on the left Windows screen, so it is basically saying that you need to understand first what are octal values. So, when a Linux file permission are represented by numbers, it's called a numeric mode. Or in a numeric mode, a three-digit value represents specific file permission. For example, 744. we will see when we'll do the practically. So these are called basically octal value. So the first digit is for owner permission, and the second digit is for the group permission, and the third digit is for the other user, which is as same as this. So as it's the same basically, but it is basically in the numeric format. That was basically in symbolic format. That's how it is simple. So each permission has a numeric value assigned to it. So for example, if I want to assign the file.txt read permission, then I will use 4. Instead of specifying r, I will use 4. And for the write permission, instead of using w symbol, I will use 2. And for executable permission, instead of using x, I will use 1. So this is basically the numerical format. And if we add this 4, 2 and 1, then it will form 7. So 7 is the highest level of privileges or the permission number of the numeric permission format system. If you focus the 744 permission value, then you can dictate that the first 7 is for the user, and the 4 is for the group, and the last 4 is for the other user, which is basically says which it says by adding up the value of each user classification, you can find the file permission. For example, a file might have read, write, and execute permission for its owner, and only read permission for all other users. That will basically look like this. You can see. So if it is has the RWX in the for the owner, then you can see the R, which stands for the for a numerical representation, and the 2, which is the writable permission. 2 is basically for the writable permission, and the 1 is basically for the executor permission. So it totally form 6. And for the group, if it is set to like this, then in the numeric format it will be like this: the R for the read permission. And if it is the double hyphen, that basically simply straightforward means that it doesn't have any permission, so that's why it is a 0. So it only has the value 4. And for the other user, if it is set it to like something this, then also it is the same as that means the other user only has the read privileges, and in the numeric format it will be only 4, and the formation of all this permission will be 4. So that's why if we add this, then the result produce the 3-digit value of 744. So that's it, simple as it is. So let us just do practically what we have talked about. So let us just consider now the info.txt right now. So here is a file which is info.txt, as you can see on the screen right now. So if you are able to now if you are able to read this file permission, then you can see that the user of the file is root, where in our previous case, in the file.txt's user were Rajan, but in the info.txt files user is root, and also the group is root, and this file also doesn't have any content. That's why it is 0, and that's how it is. So it is also a basic regular file. That's why it is it's basically this the symbol of the first placeholder is a hyphen only. What the permission string says that the user root has the right read and write privileges or the write permission on the info.txt, and the group, which is root, who also has the read privileges only, and other such as other users only has the read privileges. Or to play around the file info.txt, I need to become root, not the user Rajan. So currently I am user Rajan. So I need to switch my user to root. So I will use the command sudo sudo, and I will hit my password enter, and you can see I am now root. You can see over here I am now root, and I am now the owner of this info.txt file. So I can now modify the file's content. So let us just do the same thing what we have did with our previous file, which was file.txt in the symbolic format. So let us just do the same thing with the numeric format with the info.txt. So let us consider I want to assign the executable permission to the info.txt. So in this case, I will also use the chmod command, but in this case, without using the symbolic representation of permission values, I will use the numeric format. So what we have did to assign the executable permission, which is the user, and then plus I was using the X option basically, and after that info.txt. This is the case which we have seen in our symbolic method format, where we have used the X symbol. But in this case, for the numeric format, instead of using X, I will use 1, as because you can see, if you focus on the left screen right now, then you can see the executable permission holds the or you can say the octal value, which is 1, which is the numeric representation permission symbol of the executable permission. So let us just hit enter. Sorry, I have some kind of mistake over here. Let me just check. So sorry, I was having I had a mistake over here. And that basically I need to specify it in a numerical format only, which is the I need to specify 7 over here. That's because it already has the read and write privileges, which is the 4 and 2, and I need to only specify the executable permission, which is 1. So if I combine this, then 4 plus 2 plus 1 is 7. Then so that I will use the 7 option here, and after that I don't want to change these things for this permission over here. So that's why I will use the 0 option to tell this command not to modify the permission for the groups and other users, only modify the permission for the user root, uh, basically over here. So I will hit the command enter, and if I show you, then you can now see the permission table has successfully been modified, and you can see this is the this is basically the permission value, which is X, which I wanted to set the executable permission to the info.txt. But I have did another mistake, which is I have removed all the permission from the groups and other users by specifying 0. So basically, I was wrong that I need to, if I need to when if I need to keep all these other permission is, then I need to specify the 4 and 4 option here, which is 744, to keep the changes as it is. So again, I will use, instead of using 0, if I use 0, then it will remove all the permission from the others and basically groups. So in the case, I need to specify the double four. The double four is basically for, if you consider, if you focus over here, then you can see this section is for the uh, this section is for the group. So in the group privileges, or in the group permission, this is all there was only R, and the R stands for read permission, and the read permission holds the value of 4. So I need to specify 4 over here, and same as the other user. So if I hit the enter and list again, where was the info.txt, then you can see, and now this is same as it was previous. So that's how it works. So the conclusion is, always be careful when while you specifying permission, as because it's a very careful method. You need to focus on it. So let us just see another example. So if I want to set these things, or these permission into all the RWX, and RWX, which is the read, write, and executable permission for users, for groups, and for others. In that case, I will use command. In the place of double four, I will use double seven, which is basically the combination of all permission, and I will hit enter. Then if I again list it, sorry, if I again list it, then you can see all the group others and the current user has read, write, and executable permission right now. So basically, in this way, you can modify or you can play around permissions of a specific file. So it is the same applicable up to the directory. So you can see this is a directory over here which name is test. You can differentiate or you can detect whether it is a directory or not by watching at the first symbol as the placeholder of the hyphen symbol, where it was a hyphen symbol that was a regular file, where it is a d, that means it's a directory. So this chmod command is same applicable for directory. Let me just show you a quick example. If I want the other user, you can see this is the placeholder of other user, and the other user has executable permission right now. So if I want to remove the executable permission from others from the test directory, then I will use the chmod, and in this case I will use the numerical format to illustrate it more. So let me just clarify it how you can use it. So as the current user has RWX permission, so you need to specify seven option here to keep remain unchanged the permission. And after that, you can see this is the R, and in the middle there is a hyphen and the X. The group user only has the read and executable permission. So the read is the 4 and the X is the 1. So 4 plus 1, what is a 5. So I need to give the 5 to keep remain unchanged it. And after that, I can see that this is the and this is the other user's permission section, and this other user has the write and executable permission. So I need to remove the executable permission, so that's why I will only use 4 over here. So to remove the permission, I didn't specify 5 over here. So that's how it works. So now let us keep the info.txt, and it has been successfully executed. Let us just see what has happened over here. As you can see, sorry, something I have did wrong. Oh, okay. I did a mistake that I gave the wrong file. I want to implement in test directory. So let's just give the command again. So you can see now right now the executable permission has been removed from the test directory. So if I want to create a file, if create a file inside the test directory, then I can the touch command. Okay, I need to cd and then touch and then apple.txt, and you can see this is the apple.txt over here. And just note this permission right now, and I am getting back from the directory, and let us just see what I am doing right now. This is the test directory, and if I use the command chmod, and then if I use hyphen hyphen capital R, and then if I use 777 and then test, and just note it, and just note this command and note the previous permission over here, and just see what will going to happen. And I will list the content again, and you can see. And you can see right now all the file permission has been modified, including the apple.txt, which is inside the test directory. Here, the hyphen r option is not for the read permission, it is basically for the recursive option. If it is a capital R, then it is basically for the recursive permission that basically specify that including all the directories and subdirectories and subfolders, subfiles, and other everything inside the particular directory will be set the permission, or will follow the permission list, or will they follow the permission instruction basically. So that's how the recursive option work. So let us now quick jump into another command, which is chmod. So now we have learned about changing files permission for users, for groups, for others. Now just learn. Now we will gonna learn about how to change the ownership of a file basically. As you can see, if I give the command ls hyphen l over here, then you can see the apple.txt file is right over here, and the owner of the file is root, and the group of this file is root. So what if I want to change the owner of this file? In this case, the chmod command won't work. In this case, I need to give the command, or I need to use the command ch1 basically. This command is stands for changing ownership of a file or a particular directory. So let us just see how it works. So if I want to change the apple.txt, the user root to some kind of another user which is on my system, the another user is a Rajan, which is a standard user, which is me. So I need to switch the from the root user to a Rajan user. So in this case, I will use the chon command. Then I will use Rajan. Whatever the user you want to assign the file or the assign the directory, you need to specify over here. And after that, you need to give the file and hit enter. And again I will use command. Then you can see the differentiate the difference between these two output, where it was the root user, or root was the user of the file.txt. In this case, now the Rajan has become the owner of the file.txt. So this is how we can change the ownership of a particular file. So let us just change the group of the apple.txt. So to specify the group, you need to do the simple thing, which is in case of Rajan, you just need to give a column over here, which is basically uh, for if you specify the column over here, then the right side of the column, whatever the user you specify, that will be considered as a group user. And in the left side, if you specify some kind of thing, such as let me just show you. If I specify over Raj over here, then the Raj will be the user of the file apple.txt, and the Rajan will be the group of apple.txt. So in this case, Raj is not a valid user of my system, so I am not specifying it. I am just changing the group of the apple.txt. So I will hit enter. And again, if I list it, then you can see the changes over here. The group has also been successfully changed. So in this way, you can also change group. So if I want to revert my changes, so I will do the same with some kind of modification with a within a single command. So I need to specify over here the root and root. So this command tells the Linux kernel that I want to change the apple.txt's user and the group ownership to root. I'm transferring my ownership to the root user. So I will hit enter. And if I show you, sorry, then you can see the changes has been changed successfully. So this is how you can use the chown command to change the ownership of a file or a directory. It is the same applicable to the directory. You can also do it to the directory. It is the task for you to do that. And if you have any doubt, then just comment down below. I'm here to solve your doubt basically. So let us just move to another topic. So all this permission, whatever we have learned right now and learned till now, that was the normal or the regular permission basically. So there is some kind of special permission on the Linux system, which we're gonna learn right now, which is if you focus on the left window of your computer screen, then you can see. what are special permission, or you can say what are the special file permission. So basically special permissions are available for files and directories and provide additional privileges over the standard permission sets that has been covered. So there is basically two types of special permission, or you can say that basically three types of special permissions are there. Number one is SUID, which stands for switch user identifier, and the number two is the SGID, which stands for set group identifier. And the another thing is another permission is a sticky bit permission. So let us just understand it more deeply. So basically the sweet bit permission, what it does that if a file, for example in this case, if the apple.txt have the sweet bit permission set, then it will run as the context of the of that user who has permitted the sweet bit, or who has set the sweet bit. No matter who runs it, it will basically run on behalf of that particular user who had assigned that permission to it. So that's how. So what it basically says, you can read over here. That is, suite is a special permission for the user access level, and always execute as the user who owns the file. Basically, who owns the file, no matter who is passing the command. And the same as the SGID. SGID allows a file to be executed as the group owner of the file. A file created in a directory has its group ownership set to the directory owner. This is helpful for directory used collaboratively among different members of a groups, because all members can access and executable new files. That's it exactly what it says. Last, the another cool permission is the sticky bit permission, which basically specify at a directly level permission that restricts the file deletion, meaning only that the owner of the file can remove the file within the directory. Nobody else can remove that file. That's a sticky bit permission, which is a special kind of permission. So let me just show you what exactly I am talking about. So the first case is the suite bit permission. So the suite bit permission says that the file, or the binary which has the suite bit set, it will be run as on the behalf of that user, of the owner of the file, no matter who runs it. So the symbol of the suite bit permission is S. As we have studied till now, that there are three kind of symbol, which is R, W, and X. There is another symbol which is S, that stand for sweet bit. So what if I want to set the sweet bit permission to apple.txt? So for that, the command C plus S. But before that, I need to specify the user. I want to specify the I just want to specify the sweet bit set to the user, and then I I will give the apple dot txt. And if I again long list it, then you can see the color has been changed to red highlighted. It is basically for the that I have set it the sweet bit to the for the users, basically. So whenever another user, that might be a service account, or that might be another standard user, such as Rajan, whenever they will run this apple.txt. So in technically the .txt file cannot run, as because it's not a binary file. So if it will be a .sh or some kind of shell script, then if I just specified the suite bit permission, then it will run on behalf of the root user instead of the Rajan user. So same thing you can do with the group as well as other, by specifying the G and O. You can also set the suite bit permission to others and group, as you can see, as you can read from the output. So to understand, or to explain the sticky bit permission, let me just change the ownership of the group of the apple.txt to Rajan user. As you can see, now the apple.txt's user is Rajan right now. So let me just get back to my previous directory, and you can see this is my test directory over here. And if I want to keep it permission, I will use the chmod command, and plus the T symbol is basically used for sticky bit permission, as like the read R and the write W, executable X, and the sweet bit S. The sticky bit permission symbol letter is T. So I need to give the directory name test and hit enter. And you can see no changes over here. Instead of the T symbol at the last, which basically stands for the sticky bit permission, that basically means that only the user of the file inside the directory can only able to delete, nobody else. So let us just check whether it is true or not. So as you can see, I'm inside my test directory right now, and if I want to delete the apple.txt, then let me just give a quick disclaimer that if I use the rm apple.txt over here, as because I am a root user right now, it might delete the file, as because the root is the god of Linux, or it have the highest level of privilege, all of the resources, so it may able to delete the file. But in case of it, if I can let us just imagine if there is another user for such as Bob, then Bob might not be able to delete that particular file such as apple.txt. So yeah, I was right. I am able to delete the file as because I am root. But in case of some other user, then it will be won't work. Is because the sticky bit permission allows us to set permission that only the owner of the file can able to delete that file, nobody else. As we are the root, as I am root right now, that's why I was able to delete the file. So now you have understood a lot of thing about file permission in Linux. So let us just recap what we have learned. So in the first, we have learned what is permission is, about all the about read, write, and execute permission, how to change permission using symbolic and numeric methods, master file and directory ownership using chown. Also, we have looked into the special permissions such as SUID, SGID, and sticky bit permission. Also, the advanced permissions such as recursive changes. So that's it for this video. See you in the next video. Till then, keep hacking, keep learning, and goodbye.